And here we start on today's thing, motion in 1D. This is lecture number 10, and we are supposed to wind up this entire discussion by today. Everything must have a timeline. In yesterday's class, we were discussing equations of motion. Do we remember those equations? Yes or no? This is a yes, this is a no. Okay, girls, remember? Okay, there are only 4 equations that you have to use. You have to choose the what? The equation which fits the criteria in the best possible way. I'm not going to do any recap of the last class. I'm just going to give you with this question. And I think this question is from the module that you have. Do you have the modules with you? Yes or no? Yeah, so I think you can have a look at this question. This, I think, is example number 7 taken from your module. And the question comes straight away like this. Boom. A particle moving rectilinearly with constant acceleration is having initial velocity of 10 meter per second. After some time, its velocity becomes 30 meter per second. So obviously it has accelerated. Velocity and acceleration are in the same direction. Find out the velocity of the particle at the midpoint of its path. This is how we begin our class today. Remember, choose the best possible equation. The best possible equation will give your answer in the least amount of time. Has anyone tried this question at home? Has anyone opened the book while you were in your hostel or your home? One student, 2 girls. So that one student and 2 girls might be able to solve this question quicker. Chalo. Anyways, please study at home. That is the way you are going to clear JEE. What about this one? Anyone? Can anyone tell me which equation is best fitted to do this question? Equation number 1. I hope you remember the sequence. Equation number 2 or equation number 3. Which equation do you think is fitted to solve this question instantly? 1, 2, 3. Do not waste your time in writing the question. If you want to write the question, you write it in the smallest possible way. The best way to write a question is to draw a diagram, right? Whatever things are given, and put a question mark on whatever things are not given and ask in the question. That is the way you write a question. Yes, kids. Anyone with an answer? Which equation are we going to use here? I hope we recollect the 4 equations that we had discussed. Do we recollect those 4 equations? These are the 4 equations that we had done. Equation number 1, dang dang dang. Equation number 2, bang bang bang. Equation number 3. 4th one we have not used till now. I'll tell you when we use it. The 4th one is for displacement in the nth second. Yes, my dear friends. Which one is best suited for the job? 1, 2, or 3? 1, 2, or 3? 3. Yes, 3 is the one that is best suited to do this job. How do you know that this is the best suited equation? It's revealed in the question itself. Initial velocity is given, final velocity is given, and they ask something about the displacement or distance or position. There is only one equation which relates initial, final, and the displacement. Can I have your answers, please? How you have done this? I'll give you 2 minutes. Do you have an answer, beta? No one? Shall I do it? Shall I do it? Or are you trying? I see most of the students looking at each other. Trust me, looking at each other is not going to solve the question. The only way this question is going to be solved is by your own efforts. Please try. Okay, it seems like I'll have to do it. So this is the diagram that I have drawn from A to B. It is moving. Let me call the displacement or distance. Both are same because it is moving in a straight line. At point A, the velocity is 10 meters per second. At point B, velocity is 30 meters per second. The acceleration is constant, I'm assuming. Then I have a point C, which is midway between A and B. So the distance or the displacement from A to B will be x by 2. I have to find the velocity at this point, at the midpoint of a journey. How I'm supposed to do it? First, I will make equation from A to B, for which the data is given to me. I will use equation v square is equal to u square plus 2 times a into the displacement delta r. Everything is given to me. V is 30, so I write it as 30 square. Why I'm writing plus? 30 square is equal to initial velocity is u, and u is given as 10. I hope you see this. 10 square plus 2 times, I don't know the acceleration, so let me call it at a, into the displacement. How much is the displacement? As you can see, this displacement is equal to x. I've assumed it is x. So I write it as x. This becomes my equation number 1. Do we understand this? Please raise your hand that we understand this. How many of you were able to make this equation? I don't see anyone from the left hand side of the class. Which left hand side of the class is not a part of the class, right? They have not tried anything. All the boys on the left hand side of the class, left hand side of the board. Did we try the question? Yes or no? Yes, I can see one or two raise hands. Okay. That was the part from A to B, but that does not solve anything. So I now have to move from the point A to C, and I will apply the same equation from A to C. V square is equal to u square plus 2 times A into the displacement. We have to find the final velocity. Final velocity will be velocity of C, which I don't know, so I write it as V square. If I look at the initial velocity is the velocity of point A, which is still 10, so I write it as 10 square plus 2 times acceleration is constant. It is given that it is moving with constant acceleration. You can see it. That is why you read the question very carefully. It is given that it is constant acceleration. Now I write this acceleration as a. Now look at this displacement. The displacement now is given as the midpoint. That means it is x by 2. So I write x by 2 here, and this becomes my equation number 2. Now from this equation number 2, you are supposed, from 1 and 2, you are supposed to find out the value of v square. Can you find out the value of v square from these two equations? Yes or no? Not confident? From equation number 1 and equation number 2, can you find out the value of v square? If you find out the value of v square, you will get the value of v. Yes or no? So find out the value of v square. I am not going to help you out there, because that is one part that you will have to do on your own in the examination hall. I can tell you my way. What will I do? Here I have a into x. Here I also have a into x. I will equate both values of a and x, and I will get a simple equation that can give me the value of v square. For example, I can write on the left hand side, I can write it as 30 square minus 10 square divided by 2. This is the value of ax. On the right hand side, I can write v square minus 10 square. These two will get cancelled, will be equal to a into x. This is a into x. This is a into x. Solving both the equations or dividing 1 by 2, we should be able to get the value of a and x will get cancelled because we are substituting them. We'll get the value of v. Yes or no? What is the value of v are you getting? What is the value of v that you are getting from here? What is the value of v or v square that you get from here?
Ten root 5.
10 root 5. Well done. V is 10 root 5. That is the answer that was supposed to be done by you. Now, please look at the solution and see what you were thinking. See what steps you were thinking were correct. See what steps that you were thinking were not correct. If both the steps were correct, then see why were you not able to solve the equation, because solving this equation is not a part of physics beta. It's even not a part of maths, because you must be able to solve linear equation in two variables. It's a very simple task. Everyone understands this? Can I have raise hands from everyone? Girls understand this, boys? I'll give you 2 minutes to note this down and I'll bring you the next question. Once you are done, please let me know. Done? Everyone got this? Then comes the next question, sir. And if you have the sheet that I have already sent to you, this is question number 63 from the sheet. Question number 2 for the class, question number 63 from the sheet. How many of you have the sheet with you right now? Okay. So this is question number 63 from the sheet. That is the reason sheet was given to you so that you can solve it at home. You can bring it to the class so that we can do questions from the sheet in the class. An engine of a train moving with uniform acceleration passes an electric pole with velocity u, and the last compartment passing with a velocity v. The middle point of the train passes the same pole with how much velocity? Remember, this question is of uniform acceleration, which is mentioned in the question. The engine of the train passes with velocity u. The last bogie, the last compartment, passes the same pole with a velocity v. You have to tell with what velocity the middle point of the train will pass the same pole. I'll give you 2 minutes to do this. Yes. What about this question? Everyone back now? The engine of a train moving with constant acceleration passes an electric pole with initial velocity or with velocity u. The last compartment passes with a velocity v. With what velocity the middle point of the train passes the same pole? Does this question remind you of something? Midpoint. I'll give you 2 minutes to solve it.
Option B.
Well done. I have an answer. Option B. How did you get this answer, beta? Option B is correct. How did you get it? Can anyone tell me how did you get it?
Same as last problem.
Yes, this is exactly same as the last problem. This is exactly same as the last problem. Only the language has been changed. It might look, no, it's not same as the last one, but this is exactly same as the last one. How is it same? Remember, there are different ways in which you can formulate the same problem. Let us assume that this A is the engine of the train. Or let me not write it as A, let me write it as E. E is the engine of the train. Engine. And this is the tail or the last compartment, right? The engine of the train and the last compartment. Now, this is the middle point of the train. If the length of the train from E to L is x, the length from E to M is x by 2. Now look at the question. What does the question say? There is the electric pole. Let me say that the electric pole P is here. The electric pole P is here. When the engine is passing this electric pole, when the engine is passing this electric pole, it is moving with a velocity u. But remember, this train is accelerating. So as the engine goes forward, the speed of the train increases. Yes or no? Now, what will happen is after some time, the last bogie of the train will pass this pole. The last bogie of this train, and I'm drawing the pole here. Remember, pole has not shifted. Is the engine that is the last compartment that is passing it. Do we understand this? The last compartment passes the pole with a velocity v. But at that time, what is the velocity of the engine? The velocity of the engine would also be v. Yes or no? That means the question now becomes very simple. When the engine crossed the pole, the velocity was u. When the entire train passed the pole, the velocity was v. With what velocity it will pass this point? So you can solve this question from the point of view of the engine. So if I call this velocity, I'm using u and v here. What should I use here? Let me use s here. If I call the velocity as s, I can make two equations. The first equation will be the initial velocity of the engine is u, the final velocity of the engine is v, and the distance or the displacement is x. Do we understand this? That will be my first equation. So my first equation will become v square is equal to u square plus 2 times a into x. That is the first equation. For the second equation, what will I do? I will take initial velocity as u and the final velocity as s, and the distance as x by 2. So my equation number 2, if this is equation number 1, my equation number 2 becomes the velocity is s square is equal to u square plus 2 times a into displacement is x by 2. Again the same thing. You look at this equation or look at that, both are same. Now you can find the value of s square, which is the speed which the middle point crosses the pole, and you will get s square as, or s as v square plus u square by 2 under root of this. And you can check it. If you use this same equation in the previous question, v was 30. 30 square is 900. U was 10. 10 square is 100. 900 plus 100 is 1000. 1000 divided by 2, root over 500. And that was the answer of the previous question. Do we understand this? Yes or no? So remember this formula. If you can remember this, and if this question comes, you can straight away use this and move on to the next question. Remember, JEE is not clear in the examination hall. It is clear right here. Whatever questions we are doing, if you can remember them, I know you may not be able to remember all of them, but even if you remember 10% of them or 20% of them on the last day, I'm sure that 10 or 20% is going to help you out, and you will be clearing JEE with flying colors. Do we understand this? Can I move on to the next one? I'll give you 2 minutes to note it down. Note it down and we'll move on to the next one. Everyone understand what we discussed in the first two problems? Yes or no? Can you move on to the next one?
Yes, sir.
Here it comes. A body having zero initial velocity is moving with a uniform acceleration of 8 meter per second square. The distance traveled, instead of distance traveled, you can also write it as displacement. Find the displacement of the particle in the fifth second. In the 5th second. I hope you understand the meaning and you shall give me the answer.
36.
Eh? So quickly, well done. I'm impressed. I've got an answer. What about the others? Can I have the answers from everyone in the class? That gives me more confidence that we are doing good. The thing that you have to understand here is which formula are you supposed to use? 1, 2, 3, 4. Which one? Which one? And the answer is 4, my dear friend. 4, 4, 4, 4, 4. The displacement in the nth second, nth, first, second, third, fourth, fifth, sixth, seventh, nth. The displacement in the nth second is u plus a by 2 times 2n minus 1. We just put the values here, my dear friends. The second given is fifth, so displacement in the fifth second will be equal to u. U is 0, my dear friends, plus acceleration a is 8. 8 by 2 times 2 into n. N is 5 minus 1. I hope you can do this. And what you will end up will be 9 into 4. That will be 36 meters. Do we understand this? Yes or no? No, yes. Huh? Paka? I'll give you 1 minute to note this down, and I shall bring the next question for you. I hope if you are reading, if you are writing the question, you are writing it in the smallest possible, quickest possible way. Yes or no? Let me know once you are done so I can move on to the next question. Are we ready? Everyone?
Yes, sir.
Yes, sir. Then, sir, this question, sir, for you, sir. A body starts from rest. Good. With an acceleration a1. After 2 seconds, another body starts from rest with an acceleration a2. Very good. They travel equal distances in the 5th second after the start of A. So time starts when A starts. Then the ratio of A1 by A2 is, and your time, my dear friends, starts now. Remember, the answer to every question is hidden in the question itself. Question only tells us how I am going to get solved. And the first thought that should come to your mind whenever you see any question is that it is a simple one and that you can solve it. Remember, JEE is cleared in the classroom and not in the examination hall. 2 minutes. And whatever question you are going to do, you do. If you remember, more than 60 or 70% of it, no power in this universe can stop you from clearing JEE. No power in the universe. Dark matter or not. No one can stop you. More than 60% if you remember. Let's see how you can do this one. Shall I do it for you?
A.
A, 5:9. That is correct. Well done. What about the others? How many of you got this answer? A is the correct answer. 5:9. Eh? Okay, students from the left in the front bench, I can see your hands. Well done, beta. I understand that raising hands every time may give you some discomfort, but try to understand that that is the only way I cannot see all of you. Problem is this. So if you raise your hands, I get to know that you are getting it. Girls, what about you? No answers? Okay. How are we supposed to solve this? So basically, which formula are we going to use? Formula number 4. Displacement in the nth second, I will write the formula once again. Why I write the formula? So that the more number of times that you see the formula, the better are the chances that you will recollect it. Now, what I'm going to do is, first of all, I'm writing the equation for body A. Now, for body A, what is the displacement in the fifth second? It's very simple. For body A, the displacement in the fifth second would be, and you are not able to see my screen, so now you are able to see the screen. Okay, the displacement in the fifth second for body A, both the bodies start from rest. A also starts from rest. B also starts from rest. For A, displacement in the fifth second will be 0 plus acceleration is A1 by 2. Acceleration is A1 into 2 into 5 minus 1. Do we agree on this? This is for A, only A. This is for A. But what about B, my dear friends? For B, B starts 2 seconds after A. So, fifth second for A is actually which second for A? For B? It is the third second for B. Yes or no? Do you understand this? B starts 2 seconds later. Therefore, the fifth second for A is the third second for B. So I have to find out the displacement in the third second of B. 0 plus acceleration is A by 2. Acceleration is A2. 2 multiplied by 3 minus 1. This is the equation, my dear friend, that we are going to get for B. Yes or no? Do we understand this? Yes or no? Please raise your hand so that we understand. Now both the displacements are same. I am not going to solve it any further. From here, you should be able to get me the ratio of A1 and A2. Equate both. You will be getting the ratio of A1 by A2, and the ratio that you are getting of A1 and A2 is how much? I think it is 5/9. Can I have raised hands from everyone that we have understood this? Everyone has noted this down? Yes or no? No, yes. Well done. That is good. See, the only thing I expect from you are two things. Number one, you try all the questions that I give you. Right answer or no answer doesn't matter. Even if you can do any one question, that means you have done all the questions before that. Number two, when you go back home, you please try more problems. Try the problems in the sheet. If you can do that much, I can assure you
Completed, sir.
that you should be able to clear JEE. Can we move on to the next one? Yes or no? No, yes. Everyone has noted this down? And I am only giving you those problems which have previously come in the JEE and are likely to come again in the JEE. This is a problem which has been repeated multiple number of times, similar to the problem of the train and the last bogie and the front engine. Same problem has come many times. This is the problem that has come many times. Sometimes even the time interval is same. This is the next problem. I have forgotten the number. I will call it question number 6. A body travels for 15 seconds starting from rest with constant acceleration. If it travels, it's moving in a straight line. It travels S1, S2, and S3 in the first 5, next 5, and the last 5 seconds. What is the relation between S1, S2, and S3? Your time starts now, my dear friends. Do we have an answer for this one, bacha? Shall I do it for you? Shall I do it? Okay, so here we go. This is the journey that I have written, A to B, then we have C, then we have D. At point A, it is at rest, so velocity is 0 at point A. From A to B, it takes 15 seconds, so this is the first 5 seconds. First 5 seconds here. Then from C to D, it is again the next 5 seconds. And from D to B is 5 seconds again. Do we understand this? Yes or no? This is what is given. From A to C, the displacement is given as S1. From B to C, C to D, it is given as S2. And from D to B, it is given as S3. And I am supposed to find out the ratio of S1, S2, and S3. How are we going to do this? Very simple. I will make first equation from A to C. Now see, I am going to solve it. First equation is made from A to C. Which equation should I use? That is the first question. Let us see. Let us see what we have. We have the displacement, we have the time, and we have the initial velocity. Which equation should I use? Displacement, time, and initial velocity I have. Which equation should I use? First, second, or third?
Fourth.
First, V is equal to U plus AT. What will I get from there?
Fourth, sir.
Fourth. Why fourth? Fourth is the displacement in the nth second. It is not displacement in 5 seconds. It is displacement in 5th second. There's a difference. Displacement in 5th second means between 4 to 5. That is the 5th second. So which equation I should use? Displacement is given, U is given, T is given. I must use equation number 2. Do we understand this? Displacement. How much is the displacement? I am not going to write the equation because I've written it many times. Displacement is S1 will be equal to U into T. U is 0. 0 into T is 0 plus half. Acceleration is constant. It is given constant acceleration into T square. How much is the time it has taken? 5 seconds. 5 square. So S1 becomes 25 by 2a square. Do we understand this? Yes or no? Now comes the next part. Now from where to where I should make equation? See, if I make equation from C to D, let us suppose if I make the equation from C to D, the problem is I don't know the velocity at C. To find out the velocity at C, I will again have to go from A to C. Let us not do that. Let us be smart. So what is smartness? I know that the velocity at A is 0. So instead of making equation from C to D, let us make the equation from A to D. Do we understand what I have done? I can do that because the acceleration is same. Do we understand this? If the acceleration was different, I could not have done this. Since the acceleration is same, I can do it. Now I will make equation from A to D. Again, I will use equation number 2. What is the displacement now? Can you see and tell me what is the displacement? Displacement now is S1 plus S2. Yes or no? No or yes? That must be equal to ut plus half at square. U is 0. Half at square, half into A. But now how much is time from A to D? 5 plus 5, 10. 10 squared. So from here I will get S1 plus S2 is 100 by 2A. Why I have written A square here? 100 by 2A. Do we understand this? Yes or no? But my dear friends, we already know the value of S1. So now it is very simple to get the value of S2. What is the value of S2? You will get no prizes for guessing this. I think you would get 75 by 2A. Yes or no? What would I do next? Is anyone guess? I will now make the equation from D to B. If I will again be caught. I will make the equation straight away from A to B. I can do this because it is a motion with uniform acceleration. What is the displacement now? My displacement has become S1 plus S2 plus S3, and that is equal to 0 plus half into A. Into time is 15 seconds, so 15 square. From here I can get S1 plus S2 plus S3 is equal to 225 by 2A. I already know, my dear friends, what is the value of S1 plus S2. S1 plus S2. I can calculate the value of S3. What is the value of S3 coming, my dear friends? I think it will come as 125 by 2A. Now I know S1. Now I know S2. You should be able to tell me the relation between S1, S2, and S3, and which is the correct answer. The correct answer is option C. Do we understand this? Yes or no? Is this question clear to everyone? Well, everyone understands this? How I have done this? We will continue with uniform acceleration in the next class. Please note this down. You have a sheet with you. All the questions will be there in the sheet in some form or the other. Please solve the sheet and come in the next class. In the next class, we might also start with motion under gravity. We will start with motion under gravity. We'll do one or two more problems so that each and every problem is covered. We'll meet in the next class. Everyone has noted this down, yes or no?
Yes, sir.
Take care and enjoy your life. Bye bye. Please come studying and solving some problem. That is the least that you can do. That will help you. Bye bye.
Thank you, sir.